So to bring this lesson on pricing to a close, we need to know when a business actually starts making money. And this graph helps us understand the answer. The dark blue line shows total sale revenue. Every time a customer buys a product, that line goes up with units sold. More sales, more income. Simple enough. Now, look at the red line. That's total cost. This includes both fixed costs and variable costs. Notice that the red line starts above zero, even before anything is sold. That's because fixed costs like rent, insurance, and salaried staff don't change with how much you sell. You pay them no matter what. But then the red line starts to slope upward. That's where variable costs kick in. These are costs like ingredients, packaging, or hourly labor. The more you sell, the more variable costs you take on. So the red line climbs with every additional unit that you sell. The blue line is also rising, but at a different rate. And the point where these two lines meet is called the break-even point. The exact moment where sales revenue equals total cost. No profit yet, but no loss either. It's the tipping point where the business starts to shift from losing money to making money. And there are two ways that we can measure this. One is by how many units you need to sell. That tells you quantity. The other is by how much revenue you need to bring in. That tells you dollars. Both get to the same goal, to figure out what it takes to stop losing money and start profiting. And we'll cover them both clearly and directly, starting with break-even points in units. The break-even point in units tells us how many individual items we need to sell to fully cover our costs. And the formulas here are a little bit weird. Break-even in units is equal to your fixed costs divided by the difference between selling price and variable costs. And I'm sorry to say, but if you want to get these questions right on the RD exam, this right here is an equation that you'll need to memorize. But I can make that easier by breaking down each part. Fixed costs are the costs that stay the same no matter how much you sell, like rent or equipment leases, an annual software subscription. They're predictable and constant. Variable costs, on the other hand, change with volume. Each time you make or sell one more item, you take on more cost. Think of ingredients, takeout containers, or hourly labor. The more meals you serve, the more these add up. And the selling price is how much you charge per item. This is the same selling price that we calculated earlier using the markup factors. So this denominator right here, selling price minus variable costs, is called the contribution margin. It represents how much money from each sale is left over after you cover the variable costs. That leftover amount is what you can use to chip away at your fixed costs. So the formula tells you, how many times do I need to earn that contribution margin before I've paid off all of my fixed expenses? And once you hit that number, any additional sales are pure profit. So let's try to apply that with this freaky equation right here. This meal delivery service has $15,000 in fixed costs. Their variable costs are $10 per meal. Do you notice that is given per unit? $10 per meal is per unit. This problem asks for how many meals, how many units will the company need to sell at $25 a meal in order to reach the break-even point. So this is a break-even question asking per unit. So we're using this equation, fixed costs over selling price minus variable costs, to figure out the break-even amount in units sold. And these things are given to us in the problem. The fixed costs are $15,000, the selling price is $25 a meal, and the variable costs are $10 per meal. So this denominator comes out to be 15 because 25 minus 10 is $15. That $15 means each meal sold contributes $15 towards paying down the company's fixed costs. And $15,000 divided by $15 is $1,000. Oh, in dollars, they cancel out here, right? We have $15,000 on the top, $15 on the bottom. Meals also on the bottom. We're left with 1,000 meals. That means that after selling 1,000 meals, the business stops operating at a loss and breaks even. Selling more than 1,000 meals means that they are earning a profit. Let's look at this from a different angle, from total revenue instead of just units. This equation can be more abstract, but it's incredibly useful if you want to know how much money needs to come in order to overall break even. So the formula here for break even in terms of dollars is to take your fixed costs and then to divide it by the ratio of variable cost to sales that have been subtracted away from 1. We're still working with the same 3 variables, but instead of calculating how many things we need to sell, we're asking how many dollars of sales do we need to generate? And what we have to look at here is this denominator. Let's try to unpack it. Variable costs divided by sales tells us what fraction of every sales dollar is going to pay the variable costs. So think of it like this. Out of every dollar you bring in, a slice of it is already spoken for. That slice goes straight to covering the ingredients, the packaging, and the labor tied directly to that item. Anything that rises with each unit sold. The larger that slice, the less of your dollar that's left over to cover your fixed costs or generate profit. When you subtract that number from 1, we find out what proportion of every dollar is left after covering these variable costs. That remainder is called the contribution margin ratio. It's the percent of every sales dollar available to cover fixed costs and build profit. So when we divide fixed costs by that contribution margin ratio, we're asking, how many dollars of revenue do I need to bring in if only a fraction of every dollar is contributing to my fixed costs? It's the same logic as break even in units, but now we're measuring total sales dollars. And this is yet another equation that you would need to memorize for success on the RD exam regarding break-even point. But let's try to walk through this final example to solidify the concept. A restaurant is introducing a new entree and they want to sell the entree at $40. But there's $20,000 in fixed costs and $15 a meal in variable costs. So the restaurant is trying to figure out what the break-even point should be. We'll start by calculating the contribution margin ratio. That's 1 minus variable costs over sales price. So we're going to divide 15 by 40 and then take 1 away from that. But let me back up. The fixed costs here are $20,000. The variable costs are $15 and the sale price is $40. When we take 15 and divide it by 40, we get 0.375. That means 37.5% of every dollar earned is spent on variable costs. So when we subtract 1 minus 0.375, we get 0.625, meaning 62.5% of each sales dollar is available to cover fixed costs. Now you'll take your fixed costs, $20,000, and divide by that contribution margin ratio, gives us the break-even value in sales dollars. So the restaurant has to take in $32,000 of sales in order to break even. So when it comes to break-even point, you really need to pay attention to what we're being asked to solve for. When you're solving for units, and by units we're talking about meals sold or number of individual items that need to be sold, number of sandwiches, number of smoothies. If the problem asks for a specific number of units, we use the selling price directly to calculate the contribution margin per unit. The denominator here tells us how much of each individual sale contributes towards the fixed costs. But if asked about revenue or sales dollars, we aren't thinking about the individual units sold. So instead of focusing on just one sale, we look at how much of each sales dollar remains after the variable costs are accounted for. That's the contribution margin ratio. So the decision comes down to the units. If the question asks about number of meals, think per unit. When calculating units, we use selling price directly in the formula. And if it's about total sales, think per dollar. When calculating revenue, we use selling price as part of the ratio to determine how much of each dollar is usable beyond variable costs. That shift is what determines which equation you use.